Today, I want to talk about crap. And no, it's not that kind of crap. I'm talking about the abbreviation which stands for Change Risk Anti-Patterns Index. And it's designed to find risky functions in your code which are highly complex but poorly tested. It's not a particularly new concept, but one that has gotten my attention recently thanks to a package released by Alexander Prohorenko called Cargo Crap, which identifies these key functions in Rust code. The original idea for the crap metric comes from Alberto Savoia and Bob Evans, who invented the metric back in 2007 while experimenting with automated developer testing tools. But Alexander recently reignited attention to this forgotten metric by writing this insightful blog post about it, and how nowadays, when almost all of the code is written by AI agents, it's more important than ever to scan your code base for these hidden issues. It's a very cool concept, and we're going to explore it in more detail in today's video, so let's dive into it. To understand why this matters, let's look at this function on my screen. It handles a multi-step data transformation with deeply nested match statements, a few loops, and plenty of error handling paths. So its cyclomatic complexity is quite high, around 15. Now, if you're not familiar with the term cyclomatic complexity, it's basically a fancy way of measuring how many different paths a piece of data can take through your code. Every time you write an if statement, or a match, or a while loop, or a catch block, you're creating a fork in the road, and the more forks you have, the higher the complexity score goes. And the harder it becomes for a human brain to map out every single possible outcome in a function. So that's why whenever possible, we try to split functions into smaller tasks. And for this function on my screen, a complexity of 15 means that there are 15 entirely separate paths this logic can execute from start to finish. Now, if this function is fully covered by unit tests, its crap score stays at 15. It's complex, but it's safe because we're validating its behavior. And this is what we should expect when we run Alexander's tool, Cargo Crap. And here we see that the score is 13, not 15. It's probably because the library didn't take the error handlers into account. But anyway, 15 and 13 are quite close, so basically this tool is doing what we expect. But let's look at what happens if someone deletes those tests, or if an AI agent generates this function from scratch and skips writing tests completely. So in this example, I'm just going to comment out my tests. And if we rerun Cargo Crap again, suddenly that score shoots past 100. So it uses a straightforward formula to calculate risk, balancing cyclomatic complexity, the number of linear execution paths through your code, against test coverage. So if we look at this function, C is the cyclomatic complexity of the function, and cov is the test coverage expressed as a fraction between 0 and 1. And the math heavily penalizes complex code that lacks tests. So if your coverage is 100%, the entire first path of the equation drops to 0, and your crap score simply equals your cyclomatic complexity. But if your coverage drops, the cubic exponent on the left side causes the risk score to skyrocket. And a function with a complexity of 10 and 0 coverage yields a crap score of 110. And this is good because if you want a code base where, let's say, for example, no function exceeds a cyclomatic complexity of 5, then this is your base metric to watch out for. And if any function gets higher than 5, you know that this is the area to pay attention to. Normally you would allow for a higher complexity. Cargo Crap has a default set at 30. But I'm just saying that you can set this metric on your own how you please. And so basically this is a good middle ground metric to pay attention to. And this becomes critical in the era of AI-generated code, because AI agents are incredibly good at spitting out these highly complex, syntactically correct code blocks that handle edge cases you didn't even think of, but they're notoriously bad at writing meaningful, robust integration tests unless explicitly forced to. So tools like Cargo Crap are meant to be run as a second check after running all the unit tests to assess the overall code quality. So basically it acts like a heat map for your technical debt, pointing you directly to the code that is most likely to break during a refactor. And this is also especially helpful if you want to keep your code base well structured in case you need to onboard a new engineer, on your team. And we know from anecdotal accounts how insanely out of whack codebases can get with all this AI generated code nowadays if we don't pay attention to it. And sometimes these AI agents also have a tendency to duplicate the same function across multiple files. So I think tools like these, and more importantly, methodologies like these, are important to be aware of and not to forget in our modern coding landscape to keep our code quality high. The same authors who came up with this methodology also released a crap metric tool for Java, and honestly, until recently reading Alexander's blog post, I wasn't even aware of this metric, so I'm thankful that his tool made me notice this long-forgotten engineering practice. And I'm sure that other programming languages would also benefit from such a tool, so if you're thinking of a fun project to build on your free time, go read Alberto Savoya's original post and build one for another coding language, because it could be a very useful utility for a lot of developers. So there you have it, folks. That is crap in a nutshell. That sounded funny. Anyway, what are some other long-forgotten engineering practices or metrics you know of that we should be paying more attention to in this new age of agentic coding? Let us know in the comment section down below. And folks, if you like these types of technical breakdowns, please let me know by smashing that like button underneath the video, and also don't forget to subscribe to our channel. This has been Andres from BetterStack, and I will see you in the next videos.